This is a video on troubleshooting output piping. Output piping meaning the high pressure side of the system. We covered the input piping in another video, and this one will be similar. Output piping starts at the discharge side of the pump, which is right down here, where this blue solenoid valve is, and goes up over in this direction. But the key that what I wanted to show you with this picture, it includes this gauge here and these 4 sets of solenoids here in this output piping. 1, 2, 3, 4 sets of pipe, and then here's a 5th one that go up behind the unit and up the wall here. So we'll look at other views now, but I just wanted to include the side views so you know what the piping out is coming out of the side of the unit. And here's the front view, a whole view. Again, it starts here at the top of the pump, and it's this small little hose that goes up here, and it actually goes underneath the input piping back here and comes up here and tees off. So we're going to get a closer view now. And here we are again, discharge of the pump, high pressure hose comes up, goes underneath this part of the input piping right here, comes up to this T, comes across here, and then from this T here it goes down this side of a valve assembly, several valves, 1, 2, 3, 4 sets of valves. Then it goes out of each valve through these lines right here. You can't see them all, but here's one of them, 2, 3, and 4 behind the motor there. Now, similar to the input piping, this has got some pressure transducers or a pressure transducer. This one right here. It's got a discharge pressure gauge right there, and then it's got a relief valve right here. So we're going to cover those. And this pressure transducer, like I talked about on the input side, the only difference between, well, there's a couple of differences here. One, this is a 0 to 2000 psi gauge, and typically we're running at between 600 and 900 psi. So 0 to 2000, and the output signal is 1 to 10 volts. That corresponds to that 0 to 2000 psi. So that goes back up into the microcontroller, monitors it for high pressure alarms and low pressure alarms. High pressure alarm would be if something happens that restricts the flow out of the unit and the pump wants to continue to pump. It will build up, and the set point of this is 1200 psi, and if it exceeds 1200 psi for 5 seconds, it will shut the unit down. And then there's this safety relief here, and that's in there in case there's another failure. Let's say that this particular sensor doesn't want to, or it is broken and it is not displaying the proper, or is not displaying the proper pressure out. This relief valve is set around 1400 psi, and it'll start to relieve a little bit of water through it to keep the pressure down. And then gauge displays it all. That is a 0 to 2000 psi gauge. So typically you're just about straight up when it's running. Now this device right here, this ball, we'll call it, is a pulsation dampener, and it's got a story behind it. You can understand what it does by its name, pulsation dampener, and it actually dampens pulses that are generated by the pump. Since this pump is a positive displacement pump, it actually has pistons in it that push water. Every time a piston pushes some water, a pulse of water greater than the desired output is pushed. And so what that does is creates a vibration within the piping, and then this dampener has a bellows in it that's halfway through the dampener, and that rubber bellows, I'll call it rubber bellows, goes up and down to absorb the pulses, so you don't get vibration through the system, through the pulses, because when the pump does pulse, it creates a vibration or a vibration. So as this pump is running, you can feel this discharge line here, or much of this line, and you can feel the pulsing. Well, as soon as you feel the line going past this pulsation dampener, it is not vibrating as much. So this pulsation dampener is absorbing that vibration, and it helps throughout the system to keep vibration down. Now, Danfoss pumps have 5 pistons in them, and Danfoss claims to a degree that you don't need a pulsation dampener, and I think we'll use a different word. We'll say that Danfoss says it's not necessary to have a pulsation dampener, but I have been putting them on because there still is some vibration that comes through these systems, and once you do put a pulsation dampener on, the vibration does diminish quite a bit. Now, vibration, pulsation, is system dependent. One system may have more vibration than another, and that just has to do with the resonating effect of pulsation, meaning as you pulsate, it can actually be amplified 2 degrees through some of the piping just by the actual vibration of the piping itself can kind of amplify itself as it's vibrating, depending on how the piping is anchored down. And it can change its vibration due to the frequency of this particular pump. So as the pump starts to pump faster, the pulsation actually is a little bit faster, and you can feel it in the piping. So what may happen is out within the piping in the building, there can become some different resonating pulses that can make it vibrate more or less. So what I'm saying, at a particular RPM, you can go out into the piping and you can grab it, and it might be vibrating quite a bit. And at another frequency, it might not feel like it's vibrating so much. And then you can go to a different job where there is a different installation and start feeling in different places, and you might not be able to feel any vibration whatsoever. You can feel the pulsation and maybe not so much vibration, but so each job is a little bit different. So overall, these pulsation dampeners do help, and I recommend that they go on the job. One of the other items that is in the output piping is a check valve right here. This is a check valve to make sure that water only goes in one direction, and when the system shuts off, it makes sure that high pressure water from the discharge side does not make its way back into the input side of the pump. There is also a solenoid valve here, and this solenoid valve is part of the bypass line, and we'll cover that in a separate video, but I just wanted to point that out at this time. And then we have the zone solenoids over here. There are 4 zones, and each one of these zone solenoids actually has 2 coils on it, and then each line goes out into the air handler, being a different zone and a different amount of nozzles on each zone. And I cover that in a separate video. The connections to these zone valves are NPT, National Pipe Thread, 3/8 inch, and there's a connection on each side, and then there's a connection out the front. The connection on this left side is the input water going into it. The connection out the front is each zone going to the nozzles themselves in the air handler, and the connection out the other side is the dump valve, or the dump portion of the valve, and that is right here. You can just barely see that piece of pipe, and they gang together, and they are a part of that top line that we saw earlier. I'll find another picture and show it to you here. This is a pretty good picture. So you can see the blue zones, 1, 2, 3, 4, and each one of these lines, there's one, these lines are the discharge lines to the zones out in the air handler, and this top one here is the dump line that dumps excess water on the off cycle out to drain. You can see that it goes into the valve here with a 3/8 inch NPT connection, and it's actually ganged down here to all 4 zones. You can see that the rest of the connections Many of the connections are compression fittings. On this particular elbow here, there's a compression fitting here. There's a compression fitting underneath this cushion clamp. Each one of these cushion clamps, there's a compression fitting that hold the rest of the piping together. A T compression clamp here. So you can easily take this system apart. However, there are places where there are more NPT fittings, where this pulsation dampener goes into this T. That's a 1/2-inch fitting. And then once we get down here, the actual hose, high pressure discharge hose, is an NPT fitting. So is this check valve and this assembly right here. Danfoss would like to see the use of JCI fittings as much as possible, but the JCI fittings are a little more expensive, a little more hard to come by as far as the right fittings are concerned. And in the United States here in North America, we have a tendency to lean towards NPT, National Pipe Thread fittings. These valves here, these with the 2 solenoids on them, they are Danfoss also. They are NPT fittings. However, Danfoss does make a valve assembly like this with British standard parallel pipe threads, BSPP fittings. And that's actually what is on this pump. Both the input and the output are BSPP fittings. So this fitting right here that comes out of the pump is an adapter that goes from BSPP to National Pipe Thread, NPT. Same with the bottom of the pump. I would like to move towards more JCI fittings, but the components needed to put this together in a JCI format are not available as let's say as easily available as NPT fittings are. So let's talk about troubleshooting a little bit. This high pressure side is not quite as straightforward as the low pressure side would be. There's a lot more that can happen. What you're up against as far as troubleshooting is a little different because you're dealing now with the pump itself, the pump doing its discharge into the piping, and what the pump does as far as its speed. It is a variable speed pump that at times regulates the output pressure and at times is bypassed through the bypass regulator. There are a lot more valves involved that could cause different scenarios. And we have the dump portion of the high pressure side, the line that actually dumps high pressure water to drain when each one of these zones shuts off. But the part that is similar to the input piping, and we'll start there, is the pressure transducer, pressure transmitter that monitors the pressure within the pipe. This is the alarm point for potential problems. Like I said earlier, it monitors a low pressure if the operation of the system falls below a low pressure point, and then there's a high point where it could actually start operating at too high a pressure. Both of those will shut the system down. Like on the input water side, it will shut the system down, and it will have to be manually restarted by pushing the reset push button or the reset that's on the front of the screen. One of the alarms, the low pressure side, is you could say a pretty important alarm. And what I mean by that is if you had a major leak, one of these fittings became loose, well, not even that, something actually came apart. One of these fittings actually blew apart, or something major happened where there is a leak in the system, and that leak is major enough that the pump cannot keep up the water supply to keep up the pressure. So what happens is when the system falls below 400 psi, when it is operational, the system will shut down. So if we were to take one of these lines and pull it off and run the system, it would not keep up to 400 psi and the system would shut down. Now, this pump has so much capacity to it with pushing against the nozzles that are in the ductwork itself. So if you do have a major leak that spills water, it's not a lot of water that you're losing. If you had an open line here, say this line was open, and you started the pump, water would just not come shooting out of here. It would come out with probably like a small stream that would go onto the floor. You know, it's a good amount of water, but in 5 seconds it would shut off. So the total amount of water that might spill onto the floor would be about 12 ounces maybe, not much more than that. So it's not like you're spilling a lot of water before this pressure transducer shuts the system down. So that's the big idea behind this, it shuts the system down if we have a major leak so we don't have water all over the place. Now I talked about the two functions of this pressure transmitter, low pressure alarm and high pressure alarm. But it does have a third function, and that is to provide the operating pressure, what the pump is operating at, back into the microcontroller, and to actually tell the microcontroller what the pressure is to regulate the speed of this pump. And if the demand changes, where the system wants more capacity, to increase the speed of the pump, which will also increase the pressure to give more capacity, humidification capacity. Now, I'm not going to talk any more than that about capacity control because I'm going to save that for a separate video. This is actually troubleshooting the high pressure side of the pump, but there is correlation there. So that's a start of bringing that up, and I may talk about it a little bit more in the benefit of troubleshooting, but that's it for now. Now, I did talk about this pressure relief valve here a little bit, and that's set around 1300, 1400 psi, and that is there just in case there's another failure with this particular pressure transducer and the pressure gets too high within the system. We've got to be able to relieve that pressure, and that's how it's done through that relief valve. Now, it's going to be pretty rare that that ever happens, because if something did happen to this pressure transducer, it would probably go out of range and it would shut the system down, even though it may not actually be out of range. Or it just is going to cause the system to do enough funny things that it'll, like I said earlier, it'll be out of range and shut the system down. Now, I have not had that happen yet. These ProSense is the name of the model of the transducer, and I've used many of those, and I have not had one of these fail yet. And that is good, because this particular transducer is seeing pulsation from the pulsation side of the pump. So there's a constant little pulsing changes on this transducer, so that means it's a pretty durable product. Continues to read good readings, even though there's this pulsation added all the time. Now let's discuss what would happen if one of these valves failed. And in the future it could happen, because these valves have a definitive number of life cycle of on and off cycling, probably around 1 million or so. I actually don't know what it is offhand, but I'm sure it's very high. And these are very high quality solenoid valves, some of the best in the industry. They are a Danfoss zone control valve. But what would happen if one of them fails? Well, how could they fail? They could fail in a couple of different ways. As I pointed out earlier, it's actually one valve. Let's restate that. Let's say it's one block, stainless steel block, and actually it's right down there. But it has two valves that are in it. So there's two valves doing two different purposes. So you could have one that may fail or another one that may fail, or both of them could fail. So what is really going to happen if something goes wrong? Well, they are energized together. As you can see, there's a power line that comes in here, 24 volts AC, and then it jumpers over to the other coil. So that means both coils are powered on at the same time. Both coils are powered off at the same time. and one is a normally open valve and one is a normally closed valve. The normally open valve is the dump side, the side that lets high pressure escape to drain. And the other one is the actual zone valve itself that lets water from the incoming side here through the valve, through this line here, out to the nozzles themselves. So that's the normally closed. So if the system starts up and this particular zone calls, power is applied to these two coils. The zone one opens up, lets water through, the dump valve closes, so there's no dump out to drain. So let's say, and that's normal operation. So let's say you call this zone to come on, and this opens up, but the dump side does not close. So what's going to happen is that water is going to come in to the zone, into the input of the valve, and go straight through and go out the bypass line to drain. So that means it would not build pressure. So the system would go off on a low pressure alarm. Let's take the next scenario. Say this zone valve works fine, but this dump valve is stuck closed. It's normally open. Let's say it sticks closed. So first off, it wouldn't cause any alarm. What the purpose of that dump valve is to relieve high pressure from this line, which goes out to the nozzle, back through the valve into the dump side to go to drain. Purpose being is to relieve the pressure within the line out to the nozzles so it prevents any dripping. So if it does not open up, high pressure would stay in that line and it would bleed down a bit to what the internal check valves are designed for within the nozzles, and it would just stay at that pressure. So it would not really cause any alarm. So let's look at the next scenario. Say this dump valve works fine, but this zone valve stays open. It's stuck open. It is a normally closed valve and it stays open. Well, a lot of things can happen there, and that depends on whether you're calling or not calling, and in which zones are calling, and how the system is actually running. So if that's the zone that was calling, say it had just come on, this one right here, zone 3, and it opens up, dump valve closes, the system would run along fine, no problem. And if you continued to have zone 3 on, and it was running fine, and you just called for another zone, it would still continue to operate properly. But once you do decide to shut zone 3 off, say there's no demand anymore, and if this thing was stuck open, it would continue to push, it would actually continue to push water out the drain, because this one would go to normally open, and this was stuck open, it would go out to drain, and the system would shut down on low water pressure. So it could stay running for a while as long as it's calling, but if it's stuck open, as soon as it's not calling anymore, all the water would go to drain and it would shut off on low pressure alarm. And let's say it was stuck closed, where it never would open up. Well, if you called for a particular zone, this is zone 3, and it's stuck closed, the processor would say, hey, we're still not getting capacity. We're still not getting capacity. Let's go to zone 4 here and turn that on, and then it would get its capacity, and it would catch up with capacity, and then it would say go back to zone 3, and it wouldn't come on. So actually it would run fine if this was stuck closed, but we wouldn't get very good capacity control. So I think that's it, running through the different variations of what happened if we had some zone control failures. If I think of anything else, I'll add it in, but what next we're going to look at is the alarm settings for this particular pressure transducer that monitors the high pressure. So here's the front display, and this is going to be similar to when we talked about the alarms for input low water pressure type alarms, or the input side, water coming in. So I'm going to zoom in here. adjust this a little bit. So I talked about on the output side, the discharge high pressure side, there's two alarms. This top one here is high output pressure alarm, and that one's set at around 1100 or 1200 psi. And I can see right here, here is the alarm set point. It's actually at 1100 psi. This is the low output pressure alarm. So there's a high output pressure alarm and a low output pressure alarm. And that's this one here, alarm setting, low output, 400 psi. Now within, when I talked about input water pressures, which was this guy over here, we talked about the time delay in seconds. And what is going on there is that once you get to this alarm threshold, it doesn't shut off right away. It's kind of a proving mechanism that says, hey, are we really in this condition? Or are we in this condition just for a short period of time, or a split second type scenario? So this is a proving 4-second condition that yes, we've gone into 1100 psi for 4 seconds, and then we shut the system down. And in order to restart it, you have to push this reset button here, or the one on the below on the panel itself. This is adjustable. You push on this particular button here and it asks you for a password, and you can change this set point. With the time delay, the same thing. You push that button there, it asks you for a password, and you can put in a new value. And the same is true on the low output pressure side. Now this is where some testing gets involved also. You can actually set these up to put them into a normal operating value that you might have to test the actual alarms. And same with this one here and this one here. So besides actually having them do their function, you can set them up to test also. Now you can see that this one is this system is not actually running. In fact, it's a new system. It really doesn't have any run hours on it at all, and that's indicated right here. Pump run hours 1, pump hours remaining before inspection of the pump 7,999 hours. So this pump has just run just a little bit, and you can see that this is the output, or this is the JCI demand. It's at 0.2. It goes from 0 to 100%. This is a stage relay, which we'll talk about another time. Output capacity minus 0.05. That means it's just not quite, it's not running, and it's a little under calibration. It actually should say 0, but the flow meter that actually is down here, flow meter says it's 001 minus 1. Well, it should say 000 or 00, a plus 1. It just happens to be into a minus, so it's giving some of this minus reading up here. Since it's not running, pump frequency is 0, and this is input water pressure. So that is the pressure that's at the incoming water transducer. It says it's 17.6 pounds. That's past the solenoid, so it's dropped off a little bit. It's not actual real pressure coming into it. And here is bypass water temperature, which we'll talk about in the bypass circuit. And here's bypass water temperature set points, pump run hour adjustments that actually adjust these run hours if you put a new pump in there or you do some maintenance on the pump. And then here's an override alarm, which we'll talk about during operation of the unit. So I think that's it for output high pressure piping, some troubleshooting scenarios, and what might go wrong with output piping. Next, we'll move into the bypass piping, explain how that works a little bit, what might go wrong with that, how it is set up, and then from there we'll move into basic operation of the system, controls itself. That's it for now. Thanks for listening. Have a good day.